everybody, welcome back boys and girls. It's your main math man, Shane, coming to you live from Walker Grant Middle School. And in this video, we're still working on that SOL review guide, and we're working on that 8.2. We're just talking about that real number system. So always be able to not only picture it in different ways, you can make a little chart for yourself like this. So I'm gonna say, all right, on my real number system, I can say, all right, I have my numbers that are not rational, the irrational numbers, and then I have my rational numbers, the ones that are ratios. Underneath of that, I have integers, whole numbers, and my natural numbers. So again, I like to use this as a way to be able to think and visualize what that chart looks like. Also, to make sure you're seeing, again, these are different sets of values. An easy way to remember it is this. If the decimal form does not end and it does not repeat, then it is irrational. If it does one of those things, it's going to be rational. If it has other qualities, meaning it's on the number line, it's an integer. If it's positive and on the number line, then it's going to be a whole number. But if it's a counting number, then it's going to be natural. So make sure you can identify those carefully. So for number one, it says identify each value that can be represented as an integer. So that's going to be the ones that are on the number line. So you could say, okay, I don't have any decimals. This is also a decimal value. Always double check though. So for instance, I would say 5 divided by -9, that's a decimal value, so that's not going to be true. However, I have -24 divided by 3. That is always looking at that result. So we'd say, yes, that one is an integer. For the next one, it says negative and then square root of 225. So this is equal to -15, which is an integer, and 8 is also an integer. For number two, you want to make sure you can fill out that chart like this. You'd say, all right, identify the relationships between the subsets of the real number system by placing the correct subset name in each shaded box. So this is just like we did before. Again, you want to make sure that you can split these into two different groups. You have the ones that are irrational. You have your rational numbers. Inside of that, again, notice how it's kind of like an onion. You're peeling away, you're getting more specific, but it's your integers. Those are still rational numbers because they are contained inside of it. Then we have our whole numbers and those natural numbers. Again, that's counting numbers which start with 1. For number 3, it says this. It says select all real number subsets to which the numbers in the set belong. So we're talking about, okay, this set of numbers, these 3 values, what are they like? Well, I can actually give those decimal values. So let's do 12 divided by 3. So we have this is equal to 4. We have a negative and then square root of 256 is -16, and 200%, take that value divided by 100 and 2. Okay, so again, we can say, all right, are these rational or irrational? Well, those are going to be rational numbers. And then from that, can we say they're integers? Well, yes, they are. We could say that each integers because they're on the number line. However, we can't say they're whole numbers because we have a -16. So since we have a negative, it's not a whole number. And then we can say since they are not whole numbers, they're not going to be natural numbers. For number 4, it says which of the following is rational number. So it must either repeat or end. It has to do one of those things. That means that for this question, we're going to have 3 irrational numbers and only 1 rational number. Again, that's the one that is displayed as a ratio. So for A, is there a pattern? No. Is there a repeating value? No. So it is not rational. However, for the second one, it does repeat, so it is rational. For number 5, it says sort the numbers into a correct column. So I think this is actually on the back here. So yeah, let me actually write this on the back. This is -2.1. We have 3/1. We have 3/5. Square root of 5. -2. And 1.0. So if we're talking about this set of values at the top, it's saying, okay, which of these is an integer and which of these is not an integer, meaning it has a decimal value after the 0, or excuse me, after the decimal place. So for instance, even though this is in decimal form, this is an integer because it's just 1.0. So you could say 1.00. So that one's good. What about -2? That's an integer. What about square root of 5? Well, let's look at that. Let's say square root of 5. That's definitely not going to be an integer. So we're going to say, we have original form. We're going to say square root of 5. We have 3/5, which is 0.6. That's not an integer. However, 3/1 is equal to 3, which is an integer. And then lastly, the -2.1 is not an integer. Same kind of setup. We have, given this set of real numbers, which ones are rational and which ones are not rational. And I always think of having pi, that 3.14159, no pattern, no repeating, so it's going to be irrational. Then we can have, what about square root of 9? Or excuse me, let's actually go in order. We have square root, let's do negative square root of 55. There's no pattern, so it's going to be irrational. However, square root of 9, that's equal to 3, which is rational. This decimal ends, and so it is rational. We can say 3.375. For this value, we notice, hey, even though it's only a small one, those 3 dots after it means it keeps going, and there's no pattern, so it is irrational. And then that 2.6 repeating is rational. So now so that was number 5 and number 6. And so for number 7, it says which of the Venn diagrams below does not correctly show a relationship between subsets of the real number system. So we're looking for the one that is false. That means 3 of these are true. We're looking for the one that is false. Okay, so let's see. It's saying, okay, I have an onion. Inside of that onion are those natural numbers. So yes, the rational numbers contain natural, so this is true. We're looking for the one that's false. What about this? How about the natural numbers? Do those contain the whole numbers? Not necessarily, because this has a 0 in it, which is not natural, so we know this is false. And we know these 2 are true, so that's why we're not picking that one. For number 8, we are placing those numbers in the correct location in the Venn diagram. So we can say this. We have the list of values that are integers, the list of values that are natural numbers, and then the ones that are both. So let's think. So anything that is going to be negative right away, we can say that's an integer. That's an integer. And then also too, we know that, hey, if it is going to be a natural number, it also has to be an integer already. So we're going to say those other 2 values are also integers. For the last one, it says all the following statements are true except, so we're looking for one false. So look for a false statement. It says repeating decimal numbers are rational numbers. Yes, that is true. So we're saying that's true. Some integers are natural numbers. Sure, that's true. We could say, 3 is a natural number, which is also an integer. For number C, it says no whole numbers are rational numbers. That's definitely false. We know that those are contained underneath of it, so we know that is false. So we're gonna actually circle that one because that's the one we are looking for. And for number 10, it's saying which one is true. So that means that 3 of these are going to be false. One of them is what we're looking for. For the first one, we know that's false. We can say the square root of 3 is irrational. So that's a false statement. For number 2, it says some integers are irrational numbers. That's definitely false. They're 2 different groups. And it says the sum of 2 rational numbers is irrational. That's also false. That would be rational. And for D, it says the smallest natural number is 1. That is true because you start counting with 1.